Pittsburgh, California, and I wanted to start a video series strictly about fractions. Fractions are at the heart of all the measurements we pull, and it's at the heart of the way that we interpret prints and what it is they want us to recreate. Myself personally, I like turning fractions into decimals and doing my math that way. I feel it's a lot easier, a lot cleaner, a lot more accurate, but you still have to understand the basic concepts of fractions. It's not going to make you any worse at math knowing how to work with these things. So I have a couple of examples I wanted to walk you through. This is going to be very basic entry-level fractions kind of work. You have to have the fundamentals and you have to have the perception of what we're trying to get across when we're talking about fractions. So down here I have from 0 to 1 inch. And in this 1 inch span, I have it divided evenly into 8 different segments. So right now we have 0/8 of an inch. But if I filled up this box right here, we would now have 1 out of 8 boxes, known as 1/8. We keep going. And we've now covered 3 out of the 8 boxes. This is all we're saying with fractions. If we go one step further, we've now filled up 4 of the 8 boxes. Now 4 is half of 8, which is where we would get 1/2, or we would get 50%. I'm a strong believer in being able to fluently move between decimals, percentages, and fractions. That is what makes the language of math and dimensions a lot simpler and a lot easier. Take it one step further, and we now have 5 out of the 8 boxes. Now, like I said, 4 out of the 8 boxes was half, or 50%. So if we filled up 5 of these boxes, and now if we divide 5 by 8, where you multiply or divide the numerator by the denominator, that's going to give you the percentage of boxes filled. So from here to here would be 62.5%. So we have 62.5% of all the boxes out of 8 boxes filled. Or if we're trying to find the decimal version of 5/8 and we divided 5 by 8, we would get 0.625 because it's not a whole. So those 3 languages, they work in tandem with each other, and it's always going to be the same. So let's just try some basic addition, keeping this in mind. That's all we're saying about it. So if we were just trying to add 1/4 inch to 5/8, we can't just go ahead and add 1 to 5 and 4 to 8. That is not the language of fractions. That is not how it works. Instead, both of these need to be speaking the same language. So essentially, both denominators have to be exactly the same before we can do anything with them. Luckily, all these numbers are going to be divisible by each other, so it's really simple to be able to do this. So we can't cut this in half, because if we cut 5/8 in half, that's going to give us 2.5/4, which that's not very good for doing our math. So instead, we're going to raise this 1/4 inch up to the same level as this. So 4 goes into 8 2 times. So we're just going to bring both of these up by a factor of 2. So now we have 2/8 plus 5/8. And something I really want you to keep in mind as we're working with this, 1/4 and 2/8 is the same exact measurement. It's just 2 different ways to say the same exact thing so we can do our math. So now we can just add across the board. We're going to keep the denominator the same. We're going to stay in the eighths, and we're just going to raise up the numerator. So 2 plus 5 gives us 7. And the eighths stay the same because that's a unit of measurement that we're working in. And we can see that 1/4 plus 5/8 will give us 7/8 of an inch. Pretty simple. We'll go ahead and work on another one. Please, if it's not sinking in, You can watch the videos over and over. I'm by no means saying that this is the only way, this is the right way. Just in my experience in working in field construction for over a decade, this is the way that makes sense to me. So we're going to take it a little bit further. We're going to do 15/16 plus 3/4 of an inch, and something interesting is going to happen here. So we know that they're not speaking the same language. We have quarters and we have 16ths. So we have to get these to speak the same language. They have to be compatible with each other before we can do any math. So once again, we're not going to reduce 15/16 down to the level of quarters. Instead, we're going to bring the level of quarters up to speak the same language as 16ths. So we know that 4 goes into 16 4 times, because 4 times 4 equals 16. So we're going to go ahead and rewrite this. So 15/16 will stay the same. And now we're going to multiply both of these numbers by 4 so we can get the bottom, the denominator, the same as the 15/16. So 4 times 4 on the bottom gives us 16, the number we're looking for. And now since we multiplied that by 4, we have to also multiply the numerator by 4. So 3 times 4 is 12/16. 12/16. If I had these all filled up in boxes along the bottom here, and if I had one set marked off in 16ths and I had one set filled up or marked off in quarters, they would take up the same amount of room, because 12/16 is exactly the same as 3/4. It's just a different way to look at it. So now we can do our math. So this is going to equal 2 plus 5 will give us 7. And now 1 plus 1 will give us 2. And then 16 plus 16 will give us 27/16. Now that is an improper fraction. We're top heavy, right? We're going to capsize the load. So 27/16 means we have more than one whole, because 16/16 would be one complete whole. If we had 8/8, that would be 100% of this. So instead, we need to change this into a usable fraction. If your boss ever came in and asked you how far is the piece off and you told him 27/16, he'd probably get pretty upset. So we know that, put this down here. Now we know 16 only goes into 27 one time, because 16 times 2 would give us 32. So we know that our whole number is going to be 1. We know we have at least 16 holes in there. So if we just stole 16 from 27, we just took it right out of it and we put it over that 16, that's going to give us one hole. We stole 16 away from 27 from the top, because we're trying to make it so it's not top heavy anymore. So really, what we're doing, we still got some left over from stealing that 17, or from stealing that 16 from here. There's still some left over on that top. Now we want to find out how much is left over on that top. So all we have to do is subtract 16 from 27 and see what's the amount left over. Now 7 minus 6 leaves us with 1. And 2 minus 1 leaves us with 1. And we're working in units of 16. So the 16 is going to stay on the bottom. So we're going to put that right back here. 1 and 11/16 is our answer. Now I understand that might be a little bit confusing. If you have to go back and rewatch it a couple of times, totally understandable. It happens to a lot of people. But if I could just try to describe it one more time, 27/16 is top heavy. We need to get that untop heavy. So we robbed 16 from this, which gave us our one hole, because 16/16 is one hole, and we wanted to know what would be left over. So as we know, 16 plus 11 would give us 11, or 27 minus 16 gives us 11, and that's where that number came from. 1 and 11/16 of an inch. I kind of feel like our books sometimes do us a disservice, because they give us the actual theory of it in the apprenticeship program. So we end up with fractions like 2/5 and 11/27 or whatever. And sometimes I feel that kind of distracts us from where we're trying to get with real, actual measurements that we're going to be seeing on tape measures all the time. I always try to stick with job site math whenever it comes to this stuff. That way it doesn't throw people off. So we've done quite a bit of addition. I'll go ahead and erase all of this so we don't start getting a little bit blurry with the numbers we're working with. So we worked on addition. The same exact rules apply for doing subtraction, except we're just going to end up with less and we might have to borrow. So if we look here, I have 11/16 minus 3/8. Once again, these two aren't speaking the same language. We got to get these guys on the same page. It's like a Boilermaker trying to talk to a pipe fitter. They're just not understanding each other. So we know that 8 goes into 16 twice. So we're going to raise 3/8 up by a factor of 2. So we're going to keep 11/16. And now we're going to multiply 8 by 2. And now we're going to multiply 3 by 2. So our new equation looks like 11/16 minus 6/16. And 6/16 are exactly the same as 3/8. If we were just working in divisions of 16, they would fill up the same amount of space as our boxes would for 3/8. They're exactly the same, just two different numbers to express the same thing. Think of it as if I had 50 cents, yeah, sure, I could have it in quarters. I could have 2 quarters as 50 cents. I could have 10 dimes. I could have 20 nickels. It wouldn't matter. It all still equals 50 cents. That's the same exact way that it works with this right here. So now we just have a simple subtraction problem. We're going to subtract the two numerators from each other, and we know that 11 minus 6 would give us 5, and we're going to keep our 16. Five sixteenths is our answer. 11/16 minus 3/8 will leave us with 5/16. So I did have one more problem over here that I just happened to erase. I'm definitely not above anybody. I make plenty of mistakes all the time. I work with math on a daily basis. I actually quite prefer math. I don't mind math one single bit. And sometimes I still get ahead of myself. I still make mistakes. That's why we rely on everybody else to work with, right? Nobody can do one thing all by themselves. So before we get into some, I don't want to say complex or advanced because it's really not. This is still basic standard stuff. But before we get into some bigger numbers, we have to go over something. 3 1/4 inch would be a proper fraction, but we can't do a whole lot of math with this big 3 hanging out. He's just sitting there and he's crowding up everybody else. So we need to get him to speak the same language as that 1/4 inch. So really, out of 3 inches, we need to find out how many quarters of an inch there is, and then on top of that, we're going to add 1 extra 1. And I know that sounds complicated. Let's just go ahead and give it a try. So really, if we want to find out how many 1/4 inches are in 3 1/4 inch, we're going to multiply 3 times 4. Now 3 times 4 gives us 12. So in 3 inches, there's 12 1/4 inches in it. If I just measured out 1/4 inches and I just went all the way across, I'd be able to count 12 of those 1/4 inches until I got to the 3 inch mark. But we already had 1 extra 1/4 inch in here. So we're going to multiply 3 times 4, which gives us 12, and then we're going to add that 1 to it. So really, what we are left with is 13 1/4 inches. If I pulled out that tape measure and I counted every 1/4 inch all the way over to 3 1/4 inch, there would be 13 1/4 inches and 3 1/4 inch. So that's really important to know moving forward, because a lot of times we're not working with less than an inch addition. A lot of times we're going to be working with larger than an inch addition, subtraction, multiplication. So knowing how to turn proper fractions into improper fractions is extremely important, and vice versa. All right, let's see. I had it written down here what the other problem was. So let's try to do 1 3/8 plus 2 5/16. Okay, now we got all kinds of stuff going on here. We got the big guys who are crowding out the party, not speaking the same language, going against the flow. We got two different denominators. So our first task is we want to get these down to improper fractions so everybody can get on the same page. So we know that 1 times 8 is 8. And then 8 plus 3 equals 11. So if I want to know how many single 1/8 inch marks there were on my tape measure in 1 3/8 of an inch, there is 11 1/8 inch marks if I counted it all the way up to 1 3/8. This number is exactly the same as that number, just a different way to describe it. So we're going to go over here and we're going to mess around with this one and make it improper. So 2 times 16, or 16 times 2 is 32. But we got extras on top. We got to throw 5 more 16ths into the party. So 32, which is 16 times 2, plus 5 gives us 37. So in 2 5/16, I could count all those 16th marks all the way up, and I would count 37 16th marks inside of 2 5/16 of an inch. Same exact number, just expressed a different way so we can do some math. All right, so now we need to get these two on the same page so they're speaking the same language. 8 goes into 16 twice, so we know we're going to be bringing it up by a factor of 2. So 8 times 2 is going to give us 16. And then 11 times 2 is going to give us 22 plus 37 16ths. And we're going to get rid of all of this over here. So 1 3/8 plus 2 5/16 when properly expressed for math is going to look like this right here. So now all we have to do is simple addition. So we know 22 plus 37. So 2 plus 7 equals 9. And 2 plus 3 equals 5. So we have 59 16ths of an inch. When we add all these together, that's how many individual 16ths marks actually go into that number. I apologize if I'm erasing this while you're trying to keep up. That's the beauty of YouTube, is you can always go back and rewind. Sometimes I do move a little bit fast, but it is just in the interest of time. All right, 59 16ths, once again, it's a good way to mess with an apprentice. If he says, what length do you need? You can tell him 59 16ths. Probably won't appreciate it too much. So we need to get this to a workable number. So I know that 15 times 3 equals 45. So I would imagine that 16 times 3 is going to get us pretty close to 45 or 50 without going over 49. So essentially we're dividing, but we're also guesstimating. So let's try it out. Let's try 16 times 3 and see what we get. 6 times 3 is 18. Carry the 1. 3 times 1 is 3, plus 1, 48. So we're going to steal 48 of those 16ths right off that guy. He doesn't need them anymore. We need to take him down to size a little bit. So we know our whole number is going to be 3. We know we have at least 3 inches in this addition. But we want to see how much we have left over. So if we're stealing 48 16ths away from that guy, how many is going to be left over this 16? Simple subtraction. So 59 minus 48, which is how much we stole from them. 9 minus 8 equals 1. 5 minus 4 equals 1. So we are left with 11/16 of an inch. Our final answer out of all of that is 3 11/16. Now real quick, just for example's sake, I want to show you something. So if you know the decimal version, I almost pulled out my calculator, but we don't even need it. If you know the decimal version of these numbers, this is a very quick and easy way to do it. This probably doesn't belong in this video, but I just want you to see the difference between the two. 3/8 is 0.375. 1.375. 5/16 is 0.3125. 2.312, and we'll just keep it there. Let's add those together. That's 7, that's 8, that's 6, that's 3. 3.6875 is the same as 3 11/16. You see how quick and easy that was? So I'm going to teach you fractions because a lot of people need help with fractions, and it is important. But also, there's two different ways to skin a cat. You don't always have to do it by making them improper fractions and flipping them back, because that can take a while, that can be cumbersome, and it's very easy to make a mistake. If you ever need help, please come down here. I'm willing to sit down with you anytime and work on a couple of these. A lot of times, there's just one little misunderstanding that opens the gates for you to be able to do this stuff very fluently. So I hope you get the education you deserve.